Okay, so we're going to go through now how do we know part two on climate change. A couple things that I hope will be a take home lesson for you from yesterday. And that is one, climate change and its history goes back 100 or more years. Now, it used to be called global warming, but scientists realized that that was deceiving because when you deal with average temperature, weather can fluctuate, right? So we might get a really cold spell here and a really hot period here. And that idea of global warming was confusing to people. What climate change means is that our climate is changing, and, however, the average global temperature is going up. That's been again discussed for for almost 100 years. The second thing is that the changes that we're observing right now, they are not consistent with fluctuations in climate from the past. The rate at which we're seeing the changes, for instance, this small degree change in temperature, might have in the past taken 5,000 years, is now happening over 100 years. And so the rate is what is alarming to scientists. Also, the amount of carbon dioxide that we're putting into our atmosphere is, if you saw from the graphs before, unprecedented. Okay, so let's go over first what our main greenhouse gases are. Carbon dioxide, methane, and nitrous oxide. Now, nitrous oxide is N2O. It's not the same as NOx, which is NO and NO2. Remember, NOx comes from the burning of fossil fuels and a combustion engine that comes out of the tailpipe of your car. N2O comes from the use of synthetic fertilizers and it enters the atmosphere that way. Now, F gases, these are your fluorochlorocarbons. These are your ozone depleting gases. They're a small amount, and again, we're phasing those out, but these are your main ones. Now, if you look, carbon dioxide is ubiquitous. It comes from all different sources, power stations, transportation, various places. When you start getting into agriculture, you start to see methane. Yes, methane comes actually from cows that, as flatulence, remember they are eating sort of the wrong foods, and so they're gassy, and that is methane gas. We also have nitrous oxide in agriculture that comes from fertilizers. Nitrous oxide is interesting. It's 300 times the infrared absorbing ability as carbon dioxide. We don't have as much of it in the atmosphere, but it can be much more harmful. Now, what I want to do next is talk to you about where did all this come from? One of the things that it kind of really surprised me was how widespread the scientific research is in this area. So I want to take you to this document. I'm going to move this over a little bit. The IPCC panel report. It's called the Intergovernmental Panel on Climate Change. And I want to read a little bit with you where this came from, because anything that you read about climate change from the scientific community comes from this document, or this series of documents. So back in 1988, the World Meteorological Association and the United Nations formed this group that they wanted to study climate. Now, note here that the IPCC does not do its own research. The research it uses are from peer-reviewed papers all over the world. 190 members from all over the world have joined this panel. I don't think there is a country on the planet that is not participating. And so you can see this list is exhaustive. All of these countries contributing to this very important document. Through its assessment, the IPCC identifies the strength of scientific agreement in different areas and indicates where further research is needed. The IPCC does not conduct its own research, so it is part of the United Nations. And this document, they publish these reports periodically about every 3 years. One's about to come out this summer, 2021. It is the most extensive and exhaustive scientific document ever published in the history of mankind. So that's an important thing. Now, this is one of the reports. This is, I believe, the 2014 report. I'm all the way at the end first because what I want you to know, people have this idea that somehow a group of scientists went in a room somewhere and they came up with all these ideas and published them, and well, that's not the case at all. The authors and review editors of this document span the globe: Argentina, Norway, Australia, India, Russia, China, Sudan, the United States, the Netherlands, Switzerland, Harvard. The list goes on and on and on. These are the scientists from these universities, institutes, the Wharton School. That's a business school, right? The Wharton School at the University of Pennsylvania. Some of the most prestigious universities and science academies on the planet contribute to this report. There's a series of reviewers. What happens is people publish articles in the peer-reviewed literature. Data that is put in this report has to be peer-reviewed by experts in that field. Once that happens and that is published, then these these reviewers will also look at the science. Austria, Ireland, Canada, Palestine, Japan. The list goes on and on. And I think it's important that students understand the breadth of this document. Okay, so what I want to do next is I want to go to the very beginning. This is the table of contents, and basically we're going to start with the summary for policymakers, because what they do is they have all this data, and then at the very beginning they summarize, which is common in any kind of article. We've got atmosphere, ocean, sea level rise, past and recent drivers of climate change, all kinds of scientific data, extreme events, and the list goes on, and mitigation as well. But let's start with the summary for policymakers, because what this does, one year I did do this with students. We went and we took the report, and everyone had a little section and they had to research it. That was really cool. I wish we had time to do that again, because we all got together and then each student got to say, well, my researchers did this and it said this, but we don't have that time. So we're going to go right to the summary, but these reports are public. You can go on the internet and you can read them whenever you want. So let's look at what are some of the fundamental conclusions of this report. Remember, the things that you hear from scientists around the world that talk about climate change and want to make policy decisions, they're talking about this report. The human influence on climate system is clear, and recent anthropogenic emissions of greenhouse gases are the highest in history. Recent climate changes have had widespread impacts on human and natural systems. Warming of the climate is unequivocal, and since the 1950s, many observed changes are unprecedented over decades to millennia. That's something we learned yesterday. I know people want to say that these changes we're seeing are the same changes we've had in the past. That is not true. The atmosphere and ocean have warmed, the amounts of snow and ice have diminished, and sea level has risen. To me, these are the three most important indicators of climate change. They are happening right now. The atmosphere and ocean have warmed. We know this. The amounts of snow and ice have diminished, and sea level have risen. Those are the three most important ones. Scattered through this enormous amounts of data, if you're a data person like I am kind of, this is land and ocean surface temperatures. The reason they usually start around 1850 is because farming communities kept really good records of temperature, and then also we have this as the Industrial Revolution started about this time. All right, causes. Anthropogenic, that means man-made, greenhouse gas emissions have increased since the pre-industrial era, driven largely by economic and population growth, and are now higher than ever. This has led to atmospheric concentrations of carbon dioxide, methane, and nitrous oxide. Remember, those are our three: carbon dioxide, methane, and nitrous oxide, that are unprecedented in the last 800 years, 1,000 years. Right? In recent decades, changes in climate have caused impacts on natural and human systems on all continents and across the oceans. Impacts are due to observed climate change irrespective of its cause, indicating the sensitivity of natural and human systems to changing climate. Now, as you go into here, they're going to talk more about, well, what are some of the things that have happened? Extreme events, cold temperature extremes, warm temperature extremes, high sea levels, heavy precipitation, and drought. These kinds of cycling between extreme events is a huge indicator of climate change. And then we're going to look at what are the key drivers. We're going to focus primarily on carbon dioxide because that is the one that we have so much of in our atmosphere, and that is what we are putting into our atmosphere through the burning of fossil fuels. And then the good part of the report is dedicated to future changes. These are done by computer modeling. They can take what has happened over the last 100 years, and then they create these computer models that say, well, if we increase it at this rate when carbon dioxide was at this concentration, maybe this could happen in the future. So the increase of global and mean surface temperatures by the end of the 21st century relative to now is likely to be 0.3 to 1.7 degrees to 2.6 to 2.6 to 4.8. The Arctic region will continue to warm more rapidly than the global mean, and I'll talk about that. These changes in temperature seem very small, but that is an enormous amount of energy, and so we'll see how those will impact us. And so there's some interesting graphics about what's happening. Changes in our average surface temperature, to 2005, and what's predicted in the future, all the way up to very warm temperatures. Changes in precipitation. You can see these areas here, more drought occurring, and the future impacts, how it will affect people, their lives, and all of this is meant to help policymakers. This is kind of interesting. This is a graphic of the changes in fishing populations. So I wanted you to see all that. What we're going to do now is we're going to talk more specifically about what it is they're saying. So let me fix this again. Okay, so you've got in front of you, I thought this was amazing. This came off of the United States report. This was published in 2018, so just a couple years ago. In 2018, the U.S. government published their research on climate change in the United States, and I got this infographic, and I thought it was absolutely fantastic. As you walk through A through L, you can see what are some of the indicators that things are going wrong, right? We have changes in average temperature. You can see here between 1 and 3 degrees Fahrenheit, so this light peach color. All over the United States, temperature is going up. Heat wave seasons. How many heat waves are we experiencing through time? Periods of percent of land area that's been affected by heavy precipitation. Remember that When you have when your temperature goes up, it causes an increase in evaporation.